we're going to be giving the face value, the place value, and the total value of each of the underlined digits below. So one thing that will help is if we have a little grid like this to put all our answers in. Number one, the digit is a 4. Number 2, the digits, the 5, the 1, and the 1. Okay, just as a quick reminder. And also another diagram might help us just think about what these digits actually mean and where they are in each number. And you can see in this particular diagram, the periods are given. So the ones period, the thousands period, the oneths period, which isn't really a period. It's just a name that I've given to this particular period here, and the thousandths period. And you've got your oneths and your thousandths because we're dealing with decimal numbers. So when we deal with the place values and the ones, it's the ones of ones, the ones of tens, the ones of hundreds. We don't usually say ones of hundreds or ones of tens. We just say hundreds, tens, ones. With the thousands, it is the ones of thousands, but we don't say ones of thousands. We just say thousands. So I'm just going to take that O away. Thousands, we do say tens of thousands, and we do say hundreds of thousands. I want to leave those there. What am I talking about, oneths? Well, in a lot of diagrams like this, you'll see the decimal point put here in between the ones period and what comes afterwards. Some people explain, or they basically categorize all the numbers, all the digits, all the place values that come after the decimal point as the decimals, and that's fine. And it's just as fine as anything else. If I'm going to keep this similar structure, though, of using periods like this with hundreds, tens, ones, it's nice to know that it gets continued, but just in reverse order. So it looks a little bit like this, if you like. I'm just going to change the tenths here. Put all our decimals in littles, so lowercase. Again, okay, hundreds. Okay, so just to explain that a little bit more, these are our tenths. Okay, these are our tenths. This is our hundredths. These are the ones thousands. So we have 1 over 1,000. We have 1 over tens of thousands. Now we don't usually write ones of thousands. And we have the hundreds of thousands. So tens of thousands. We have 1 over 10,000. And here we have 1 over hundreds of thousandths. So it looks like that is a fraction. As a decimal, it looks like 0.1, 0.01, 0.001, 0.0001, and 0.00001. Yeah, a lot of zeros. Okay. On the other hand, these ones are quite simple. This is the 1, the 10, 100, 1,000. It's a bit tricky here to fit it all in. Tens of thousands, 10,000, and then 100,000. Okay. Just so you get an idea of all of that. And you can see that the differences, if I go from left to right, the differences are decreasing by a factor of 10 each time. So it's been divided by 10 each time. And you'll notice that the decimal point is, if I put the decimal point here, it's weird that the ones of oneths column remains kind of empty. And I really like to have everything, the structure stay the same. So maybe you can think of it like this. This decimal point doesn't go in the middle of nowhere. It actually takes the place of this place value right here. So yeah, this place value does disappear, but it gets replaced. It doesn't remain kind of empty, if you like, with my thinking. Okay, so it's like this. Okay, now how will that actually play out when we come up with the face value, the place value, and the total value of every number? Well, let's try number 1. So 34. So I like to write it in reverse order, starting with the decimal point. So the 4 goes here, the 3 goes here, 0, 8, 5. Now you don't need to do all this because you only really care about the 4. Okay. So where is the 4? Well, according to this diagram, the 4 is in the ones place value. So the face value of a digit is just what it is just by looking at it. So that's a 4. The face value is a 4. The place value is in the ones. And the total value is the face value multiplied by the place value, which is 4 in this case. So the first one, pretty easy. If I do number 2, we got 0.0552. Now, we don't care about all the digits, we only care about this 5 right here. So the face value of the 5 is just what it is by looking at it. It's a 5. The place value is the hundredths. So we can put it in as a decimal, so 0.01. And we multiply those two guys. So the answer is going to be 0.0 and then 5 times 1. And that's the total value. You can put it as a fraction, and that can look like 5, and it's in the hundredths. So it can look like that. Either or, they're both as good as each other. Number 3. Okay, let's put the digits in. 5, 5, 7, 9. And I do it that way so that everything goes in the correct place value. And then I start from the decimal point again and work my way down. So 2, 0, 1. Okay, we're only interested in this digit, and that its face value is 1. Its place value is in the thousandths. So 0.001, and I multiply them. And so I can write 0.00, so I've done all that, and then 1 times 1 is 1. So that is the total value. I can just say 1 over, and what are we in? The thousandths. I can do this. And that also is correct as the total value. The last one, let's do number 4. And then 9, 1, 2, 6. Which digit? I'm looking at this one. So the face value of that is a 1. The place value is hundredths, so I can go like this. And it's just face value times place value, which is exactly the same, right? So 0.01 or 1 over 2 digits, 2 zeros, 1 over 100. Either or, they're both as good as each other. And that's how you do these particular problems.